Okay, so children, good. We're going to talk about voltage today, and so voltage in a circuit is telling us how much energy our source is putting into the circuit per the charge that flows around it, and then how much energy whatever we're driving with our circuit is taking out of it. So at the moment, the power pack here is sitting on 6 volts. That means that the power pack's putting in 6 joules for every coulomb of charge that flows around the circuit. And that same 6 volts must be over the fan here, and that's what's making the fan spin, and so it's taking 6 joules per coulomb of charge out of the circuit. And so what we can see is that if we increase that voltage up, the fan starts going faster, because now we're putting in 14 joules per coulomb, and so the fan's taking 14 joules per coulomb out. What that looks like is more power, more energy per time, and so it's spinning faster, we're doing more work. We could do the same thing with a light bulb. And so low voltage, it's not even enough for it to glow, but as we increase that voltage up to 5 volts, we get a light sort of glow, so 5 joules per coulomb going into the circuit, 5 joules per coulomb going out, and that's made that little bit of wire in there glow hot enough that it's actually letting out light. If we double the voltage up to 10, that means we're now putting twice as much energy, twice as many joules per coulomb into the circuit, and so we've got 10 joules per coulomb, 10 volts going out of the circuit, and we can crank it up even higher, up to 14, and then it really starts getting useful. So 14 volts means 14 joules per coulomb going into the circuit, 14 joules per coulomb going out of the circuit. And that's kind of our rule for, if we get a whole lot of things connected up all in a row, whatever voltage we put into the circuit with our supply has to be the same as the voltage that gets used up in the circuit. So like, we can't create energy, we can't destroy energy. If we put 14 in, we've got to take 14 out as well. We're just going to write that equation down so that we've got it for calculations. And so we write voltage, we write down that voltage is the work done per charge, or if we want to write it sort of mathematically, voltage is work done per charge. And work done just means the change in energy. So giving that equation some meaning, the energy change joules, charge measured in coulombs, and so the voltage, we could measure it in joules per coulomb, but much more commonly you'll see it measured in volts, symbol capital V. So what we should be seeing in our circuits is that if we increase the voltage of the supply, we should see more work being done, or if we're in a case where we're generating voltage, if we're turning things faster or putting more energy into the circuit, we should get a higher voltage being generated, because voltage is work done per charge.